this chapter, we are going to learn coordinate geometry of the circle. So, equation of circle, basically. Equation of circle has several ways to write it. One of the way is to write it as the center and radius form. In this particular form, you are determined center as AB, radius as R. So, because it is essentially a perfect square, so you can actually expand it. Once you have expanded, you can rewrite it in this particular form, where you can also determine the values of radius by just observing the values of G, F, as well as C. So there's another way to do it. Whichever way is easier, that would be the way of choosing. So if we are looking at this equation, we will be able to tell the values of center by asking ourselves what is the values that associate with the x perfect square. So in this case, we realize it's 3 and this is -2. The usual way of seeing this is you must have the negative sign in the perfect square, so that you will be able to tell 3 and -2 as the center. And because 25 sits at the positions where r square is at, so r equals to cert 25, which is 5. For a circle and a line, there are a couple of ways you can interact with it. So first of all, it can be a chord. A chord is something that looks like this. Basically, it's a segment of line that lies inside a circle. This is what we call a chord. It can, of course, be a radius, diameter, right? If it passes through its center, it can also be a tangent. If it only touches it once, it can also have no relationship at all, or not touching the circle at all, if it is basically just outside of that circle. Now you can also use discriminant tests to test this. Obviously, for tangent, you will have discriminant test to be 0, because you will only have one solution. Not touching means discriminant test smaller than 0. And then whether it be a chord or diameter, you will have discriminant test to be more than 0, because it will at least have 2 points of intersections. So that is 2 real solutions. If you would like to find the point of intersections, which will be also demonstrated in the next page, so we can take a look at this example on page 3. So you can once again use substitution method, which is also the method we suggested in the previous chapter, and substitute it into the other equation. So x minus 2 square plus x plus 1 minus 3 square equals to 16. X square, 4x, 4, and this is again x minus 2 perfect square. So you literally have twice of it, equals to 16. So x square, 4x, 4 minus 8 equals to 0. X square, 4x minus 4 equals to 0. And according to the discriminant test, the formula suggests to us that x equals to -b plus or minus b squared minus 4ac divided by 2a. So using the formula, we will be able to determine 1, -1, -4. The answer is going to be x equals to 4.83, as well as x equals to -0.83. Once you have gotten the values of x, you can then substitute y equals x plus 1, y equals to 5.83, y equals to 0.17, and these are going to be the point of intersections between the circles and the line. Tangent to circle. If you would like to find the equation of tangent to circles, other than what is being illustrated here, One of the other way to look at this is by first understand a very critical idea of any radius is always perpendicular to tangent of the circle. So now you will have this 90 degrees form between the radius and the tangent. So why is that important? Because you will be able to determine center. You are also told where is this point at. So you can find that gradient of the radius. Gradient of the radius multiply its gradient of the tangent equals to -1. Gradient of the radius equals to 0 minus -3, 7 minus 4, and that is a +1. Therefore, gradient of the tangent has to be -1. And then substitute into y equals to ms plus c. The value is 7, 0, gradient -1. So 0 equals to -x, 0 equals to -7 plus c, c equals to 7. So therefore, y equals to -x plus 7 has to be the tangent of this circle at this particular point, 7, 0. If you would like to figure out the intersection of two circles, the only way to figure out is by substitutions, which is a little bit lengthy, but you have to, first of all, of course, understand how two circles maybe interact with each other. It may have one of these few situations where it is not touching, where it has only touches once at one point only, or it can cross, and so it has multiple point of intersections. Discriminant test is also again useful, but discriminant test is only telling us which one of these situations it could be. It is not telling you what are the values. So for you to figure out substitutions or eliminations, whichever way is easier, we should take an approach of it. So if we try to expand it, so this is from the first equation. From the second equation, you will have something similar. If this is equation 1 and equation 2, if you try to subtract them, you'll get rid of this entirely. You'll get 9. You'll get rid of x squared. You'll have 4x minus 8 equals to 9. X equals to something like 17 over 4. Substitute back, you will be able to figure out the values of y. Okay, so that is the approach. Elimination, substitutions, whichever way that makes things easier. So remember how we will be able to determine center, radius, and then how discriminant tests can be used. How do we figure out the equation of tangent for a circle? How can we solve systems of equations so that we can get point of intersections between 1, 2 circles? Here are a couple of practice questions. I'm going to work on some of this, and then that will be all for this lesson. So if things have already got expanded, what you need to do is you need to make them into a perfect square form. And that is 25. So center is at 3 and -2. Radius is square root of 25 is equivalent to 5. So that is how the first question is done, using completing the square. We would like to determine whether or not this line is a tangent to that equation. Because this question is about determinations, so we can use discriminant test, but first we have to substitute. Discriminant test tells us that b squared minus 4ac. We can calculate it. And discriminant test suggests to us that it is a value bigger than 0, therefore it is not a tangent. If it is a tangent, discriminant test should be 0, right? If it's bigger than 0, it is a chord. It is a chord. Looking at the next questions, if you would like to figure out the point of intersections, again, as I mentioned previously, one of the few methods is to substitute or eliminate. So in this case, substitute seems like it's easier. You can use calculator to figure out, facilitate. X equals to 1.59, x equals to negative 2.39, and y value is going to be 4.18, as well as negative 3.78. Right? So these are the y values and those are the x values. So these are the 2 points of intersections. When it comes to question 4, one of the ways to do this is actually we can draw it out. So we can have our scales ready. So this is negative 2 and 1, radius is 4, 4 and negative 1 as center, radius is 3, 1, 2, 3, 4, negative 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so you have a circle that looks like this. This is this particular circle, and we use different color to represent the other one. Negative 2 and 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. Right, as you can see, this definitely crosses it, right? So it is not just having a point of intersections, it crosses it, therefore it has at least 2 points of intersections, right? So those are some of the ways we could solve some of the questions mentioned. Thank you very much.